Hello. Sorry I can't be at school today, but we need to go through lesson 5.4. So 5.4 is solving compound inequalities. The idea of today is to solve and graph compound inequalities containing the word and then containing the word or. So let's go through the notes. So here it says, when considered together, two inequalities such as x is greater than 2 and x is less than or equal to 8 form it's called a compound inequality. A compound inequality containing and is only true if both inequalities are true. So the solution must be a solution of both inequalities, or the compound inequality has no solution. Its graph is where the two inequalities overlap. This is called the intersection. So let's just look at example 1. It says graph x is greater than 2 and x is less than or equal to 8 on the same number line. Is x equals 5 a solution? Is x equals 9 a solution? So let's look at this. Okay. So first I'm going to graph x is greater than 2. So I would put an open circle at 2, and I would be going to the right where my numbers are getting bigger. Now here it says, and x is less than or equal to 8 on the same number line. So I would have a closed circle at 8 because it's less than or equal to, and less than means I'm going to the left. Now, and inequalities are true where both inequalities are true. What that means is the number that you pick has to work for both inequalities. The easiest way to see this on the graph is where your two lines overlap. If you notice, in between our circles, our 2 and our 8, you can see both the green line and the purple line. That's where the two inequalities overlap, or where they both have solutions. So when it asks, is x equals 5 a solution, look at where it lies on our number line. 5 would be right here, right in the middle of 4 and 6. Well, that area right here is true for both inequalities. So this is a yes. X equals 9, is that a solution? So 9 would be right here. Since 9 only works for one of the inequalities, the x is greater than 2, that's the one in the purple, this would not be a solution. So your numbers have to work in both inequalities. So let's look at another example. Here it says solve and graph an intersection. So we have x minus 4 is greater than or equal to negative 10, and x plus 5 is less than or equal to 4. What you're going to do is solve them like two normal inequalities, like we learned. So I would add 4 to both sides on this one, and I get x is greater than or equal to negative 6. This one I would minus 5, and I get x is less than or equal to negative 1. So my solution, because both of these are solved for x, is x is greater than or equal to negative 6, and x is less than or equal to negative 1. Now, when I graph this, the negative 6 is the smaller number, -5, -4, -3, -2, -1. Now, I'm going to draw this above the line so I can show you what my actual solution would be. So what I would do is I would put a closed circle at -6, and since it's greater than or equal to, I would draw to the right. Now the other inequality is x is less than or equal to -1. So I would put a closed circle at -1, and I would draw that to the right. My final graph is where the two inequalities overlap. So if you notice, my final answer, and I'm going to put this actually on the number line, I have a closed circle at -6, a closed circle at -1, and my solution is anything in between those two numbers, because that's where my inequalities overlapped. So if I look at B, now this one, if you notice, it's set up differently. It doesn't have the word and. But what it's telling you is that your x value has to be between 7 and 11. So notice literally the x is in between these two numbers. So the first thing I need to do is I need to get x alone. So I would -2. Now usually I would just -2 from one side, but since there's another inequality symbol over here in another number, I'm going to -2 from all three sides. So 7 minus 2 is 5. So I have 5 is less than x, which is less than or equal to 11 minus 2 is 9. Now I like the way these are set up because it makes it easier to graph. Literally, I have 5, that's my smaller number. I have 9, that's my larger number. 5, notice the inequality. It doesn't have an equal to with it, so this is an open circle. The 9 does have an equal to with it, so it's a closed circle. And literally your x value has to be between those two numbers. So that's my solution. So let's look at C. This one again, here it says and, so we've got our separated. That's okay. I'm going to first -3 on both sides. So I have 2x is greater than -8. Here I'm going to divide by -2. And I get x is greater than -4. Over here I'm going to add 2. And I get 3x is greater than 3. I divide by 3, and I get x is greater than 1. So my solution, I need the and in between here, is x is greater than -4 and x is greater than 1. So when it's not written with x in the middle, what I like to do is actually graph it above and see where my solution would be before I put my final answer in here. So -4 is a smaller number. 1 is the larger number. So when I'm graphing this, x is greater than -4. I would have an open circle at -4, and I'd be going to the right. Now I also have x is greater than 1. So I would have an open circle at 1, and I would also be going to the right. Now if you notice, this looks a little bit different. All of our other examples, the overlap of the two inequalities of the two graphs has been in between the two circles. This one, if you notice, the overlapping graphs is where x is greater than 1. So my solution, my final graph, I have an open circle at 1, and I am going to the right. So technically, if I look at my solution, I really don't need x is greater than -4 and x is greater than 1. I just need x is greater than 1. Okay, so let's go through the checkpoints. Over here, I'm going to solve them separately. So I would divide by 4, and I get x is greater than 4. Over here, I add 5, and I get x is less than or equal to 9. So the and goes in the middle, and this is my solution. Now to graph it. The smaller number is 4. The bigger number is 9. I'm going to graph this above to see where they overlap. So x is greater than 4, it's an open circle, and greater than goes to the right. X is less than or equal to 9, that's a closed circle, and less than goes to the left. I can see my overlapping is between my two circles. So my final answer, I have an open circle at 4, a closed circle at 9, and my line goes in between. So let's look at B. This one is already set up as an and inequality. So if I want to solve for x just like I normally would, I would get rid of the addition first. So I'm going to minus 6 on all three sides. So I get -10 is less than 2x, which is less than 12. Then I divide everything by 2. -10 divided by 2 is -5, is less than x, and 12 divided by 2 is 6. So this is my answer. Now this says that x is between -5 and 6. So my smaller number is -5, my larger number is 6. They both have open circles, and my line goes in between them. So that is and inequalities. Now, or inequalities, this one is true if at least one of the inequalities is true. So that means that one or the other or both. Its graph is actually called the union of the graph of two inequalities. So this one says graph x is greater than or equal to 4, or x is less than -2 on the same number line. So my smaller number is -2. My larger number is the 4. X is less than -2 is an open circle, and it's going to the left. This one is a closed circle at 4, and it's greater than, so it's going to the right. Now, the or inequalities, if it says or, that only has to be true for one of the inequalities or both. So I don't need them to be overlapping. So here is x equals -4 a solution. Well, let's find -4 on our number line. -4 is going to be somewhere over here. Since that includes one of my inequalities, right, it's where the line is, this is a yes. Is x equals 3 a solution? Well, x equals 3 is somewhere right around here. Well, x equals 3 doesn't touch either of my graphs, so this is a no. Now, or inequalities, there's no special way to write these. They're always going to have an or in between. So you literally just solve them separately and then graph them on the number line. So this one I add 5. I get 3x is greater than 12. Divide by 3. And I get x is greater than 4. This one I add 3. I get 3x is less than -9. I divide by 3, and I get x is less than negative 3. Once they're both solved for x, I write the word or in between, and this is my solution. Now I'm going to go ahead and graph it. My smaller number is the negative 3. My larger number is the 4. X is less than negative 3, so it's an open circle, and it goes to the left. X is greater than 4, it's an open circle, and it's going to the right. And I'm done. I don't have to fix my graph. The graphs don't have to overlap. This is my solution. So I do the same thing for B. Here I'm going to add 7. So I get 4x is less than or equal to 32. I divide by 4, and I get x is less than or equal to 8. Over here I minus 12, so I get negative 9x is greater than or equal to 18. I divide by negative 9, and be careful, I just divided by a negative number, so this is x is less than or equal to negative 2. So here, I've got my solution. Now I'm going to graph it. So, I have negative 2, that's my smaller number, positive 8. X is less than or equal to negative 2. This is a closed circle at negative 2, and it's going to the left. Now negative 8, that is a closed circle at 8, and it's also going to the left. Well, this is weird, because it's not the way that the other two graphs have looked. That's okay, that's going to happen sometimes. An OR inequality needs to fit one or both of your inequalities. If you notice, starting at 8, this covers one of my inequalities. Then at negative 2, it starts covering both of them. So my final inequality, I'm just going to overlap this with another color, would be a closed circle at 8 with it going to the left, because that's covering at least one solution the entire way. So my inequality is x is less than or equal to 8. That's the final inequality. So let's look at C. This one, again, it's an OR. I'm going to separate them. I minus 6. I get x is greater than 2. I minus 3. I get x is less than or equal to 6. So this is an OR. So on my number line, the smaller number is 2. The larger number is 6. I have a closed circle at 6, and it's less than or equal to. I have an open circle at 2, and it's greater than. Well, now this looks different than A and B. Now, again, OR inequalities have to be true for one of my inequalities or both. So if I look from here to 2, that works for the purple inequality, or x is less than or equal to 6. In the middle, between the two circles, that works for both inequalities, for x is greater than 2 and x is less than or equal to 6. Over here, where the red line is, that one works for x is greater than 2. So everywhere on my number line, I'm going to have a solution. When this happens, it's a special case, and what this means is my entire number line is covered. We call this all real numbers. So no matter what number you pick to plug into your inequalities, It's going to work for one of your inequalities or both. Okay. So here's our checkpoint. I'm going to have you guys solve this, and I will check it tomorrow. Also, you guys are going to work through the practice problems. So your job today is to, for homework, finish the rest of the 5.4 day, sorry, that looks bad, but it's day 1 notes. All right. I will see you guys tomorrow.